If you travel far away from the blinding artificial lights of human cities on a clear, moonless night, and look up at the constellation of Andromeda, you might notice a faint, hazy smudge against the darkness. To the untrained eye, it looks like a peaceful, glowing cloud resting quietly in the serene tapestry of the cosmos. But astronomers do not look at the sky the way poets do. When astrophysicists point their most powerful telescopes at that specific smudge, they are not looking at a painting. They are analyzing an active, impossibly violent crime scene. That faint glow is not a cloud. It is an apex predator. It is a colossal, ancient leviathan composed of 1 trillion thermonuclear furnaces, and it has a documented history of planetary and galactic slaughter. Furthermore, the forensic data we have gathered from its glowing perimeter reveals a terrifying truth: it is currently hunting us. Today, we are going to strip away the romanticism of the night sky. We are going to conduct a cosmic autopsy on our nearest galactic neighbor, uncover the grim evidence of its past victims, and simulate the apocalyptic future where it finally catches up to the Milky Way. Welcome to the terrifying reality of the Andromeda galaxy. For the vast majority of human history, this predator successfully hid in plain sight. In the early 1900s, the brightest minds on Earth operated under a comforting illusion. We believed that the Milky Way was the entire universe. We thought the dark void ended at the edge of our own stars, and that the glowing smudge of Andromeda was merely a small, harmless nursery of localized gas, a minor anomaly in our own backyard. The beast's true nature was only unmasked by the sheer brilliance of a woman named Henrietta Swan Leavitt. While studying photographic plates at Harvard, Leavitt discovered a specific type of dying star called a Cepheid variable. These stars pulsate, brightening and dimming in a highly predictable rhythm, much like a lighthouse. Leavitt realized that a star's pulsing rhythm was directly tied to its true, intrinsic brightness. She had inadvertently discovered the standard candle, a cosmic tape measure that allowed humanity to calculate deep space distances for the very first time. In 1923, Edwin Hubble used Leavitt's mathematical ruler to measure a pulsing Cepheid hidden within the Andromeda smudge. The resulting calculation sent shockwaves through the scientific community. The star was not thousands of light years away. It was millions of light years away. The illusion of a cozy, localized universe shattered instantly. Andromeda was not a cloud inside our galaxy, it was a completely separate, monstrous empire of stars situated 2.5 million light-years across an incomprehensible abyss. The universe had just expanded by a factor of millions, and humanity suddenly realized that the dark ocean of space was infested with other leviathans. Now that we possessed the tools to see Andromeda for what it truly was, we launched a full-scale forensic investigation. Using NASA's Hubble Space Telescope and advanced spectral imaging, we began to map the anatomy of the beast. And the closer we looked, the more horrifying its structure became. Andromeda is an absolute heavyweight champion. Stretching an estimated 220,000 light-years across, it is roughly twice the physical width of our own Milky Way, and it commands a staggering population of 1 trillion stars. But it did not grow to this monstrous size peacefully. Galaxies this large only achieve such mass through a ruthless process known as galactic cannibalism. If you look closely at the outer edges of Andromeda, you can find the blood spatter of its past meals. Surrounding the pristine inner spiral is a massive, chaotic halo of rogue stars and superheated gas. Woven into this halo is a structure astrophysicists call the giant stellar stream. This is a river of stellar debris stretching for hundreds of thousands of light years. It is the shredded, gravitational shrapnel of a dwarf galaxy that wandered too close to Andromeda a few billion years ago. The predator essentially tore the smaller galaxy limb from limb, absorbing its stars and leaving the mangled remains scattered across its perimeter as a warning to others. But the most damning evidence of Andromeda's violent appetite lies deep within its core. When astronomers finally peered into the very heart of the galaxy, they expected to find a single, glowing center. Instead, they found a severe anatomical deformity. Andromeda has a double nucleus. At its center are two distinct, brilliantly glowing clusters of stars, designated P1 and P2, orbiting each other in a frantic, eternal dance. NASA scientists believe this is the undigested heart of a massive victim. Long ago, Andromeda swallowed another large galaxy. The outer layers of that victim were digested and assimilated, but its ultra-dense core survived the journey to the center, where it now orbits Andromeda's own central mechanism. And what a mechanism it is! Hiding within that chaotic core is a supermassive black hole that puts our own to shame. The black hole at the center of the Milky Way, Sagittarius A, weighs about 4 million times the mass of our Sun. Andromeda's central black hole is a staggering 100 million times the mass of our Sun. It is an abyssal sinkhole that has grown fat on the cosmic corpses of a dozen smaller galaxies. And its hunger is far from satisfied. This brings us to the most chilling piece of data collected by modern astrophysics. In a universe that is constantly expanding, pushing almost all other galaxies away from us into the infinite dark, Andromeda is the terrifying exception. When we analyze the light radiating from Andromeda, we see a distinct anomaly known as Blueshift. In the physics of the Doppler effect, when an object is moving away from you, its light stretches and appears red. But when an object is moving aggressively toward you, its light waves compress, shifting toward the blue end of the spectrum. Andromeda is glowing blue. Driven by the overwhelming, invisible tethers of mutual gravitational attraction, Andromeda is plummeting directly toward the Milky Way at an unfathomable speed of 110 kilometers per second. That is roughly 250,000 miles per hour. It is a cosmic torpedo aimed squarely at the heart of our home. By running advanced supercomputer simulations, NASA has mapped out the exact timeline of our execution. For the next 3 billion years, the night sky will gradually change. The faint smudge of Andromeda will grow larger, brighter, and more menacing, eventually dominating the entire celestial canopy like a looming, glowing storm cloud. Then, in approximately 4 to 4.5 billion years, the first strike will occur. The two colossal galactic halos will make contact. From the perspective of any hypothetical planet inside the Milky Way, the sky will erupt into a chaotic, terrifying masterpiece. The immense gravitational tides of the Predator will grab hold of the Milky Way's beautifully ordered spiral arms and violently rip them open. Bands of gas and dust will be stretched into massive tidal tails, stretching millions of light years into the empty void. Despite the violence, the space between individual stars is so vast that very few, if any, stars will actually physically collide. Instead, it will be a gravitational nightmare. The delicate orbital balance of billions of planetary systems will be shattered. Hypervelocity stars will act like shotgun pellets, being expelled from the newly forming chaos and banished into the freezing intergalactic desert forever. Our own solar system's fate is a roll of the dice. The Sun and Earth could be flung to the extreme outer edges of the new galactic debris field, or we could be dragged deep into the lethal, radiation-soaked center of the merging cores. After the initial, catastrophic flyby, the two galactic cores will swing back around like two massive pendulums locked in a death grip. Over another billion years, they will crash through each other again and again, until finally, their supermassive black holes meet. The merger of our 4 million solar mass black hole and Andromeda's 100 million solar mass monster will send ripples of gravitational waves vibrating through the fabric of spacetime itself. When the cosmic dust finally settles, roughly 7 billion years from now, the Milky Way and Andromeda will have ceased to exist. They will have birthed a new, singular entity. Astrophysicists have already named this future graveyard, Milkomeda. But Milkomeda will not be a beautiful, spinning spiral galaxy. The violent merger will have scrambled all of the orderly orbits, resulting in a featureless, giant elliptical galaxy, a massive, glowing sphere of aging stars resembling a fuzzy, bloated balloon. More tragically, the collision will trigger a frantic, explosive burst of star formation, igniting all the remaining hydrogen gas from both galaxies in a spectacular fireworks display. But this burst is a death sentence. By using up all the remaining star-forming gas so rapidly, the new galaxy will exhaust its fuel supply. Milkomeda will permanently lose the ability to give birth to new stars. From that point forward, the timeline becomes a slow, agonizing crawl toward total darkness. Over tens of quadrillions of years, the massive blue stars will detonate into supernovas and fade. The yellow suns will swell into red giants and blow away into planetary nebulas, leaving behind only freezing white dwarfs. Eventually, even the resilient, slowly burning red dwarf stars will sputter and die. Milkomeda will become a lightless, stagnant tomb of black holes, frozen neutron stars, and wandering, ice-locked planets, drifting aimlessly through an ever-expanding, indifferent universe. When we map out the timeline of this grand, terrifying collision, a profound realization washes over us. No human being will ever stand on a hillside and watch the Andromeda galaxy tear across the sky. By the time the collision begins in 4 billion years, our own sun will have expanded and boiled the Earth's oceans away. We will be long gone, or we will have moved on to other shores. We are essentially cosmic detectives, using mathematics and telescopes to write the history of a future we will never see. We are compiling a time capsule, a message in a bottle cast into the dark ocean of time, proving that for a brief, beautiful moment, a tiny species on a pale blue dot managed to figure out the ultimate fate of the titans that surrounded them. Pause for 2 seconds, let the ambient music swell. Does knowing that our entire galaxy is destined to be destroyed and remade change the way you value our current, quiet era in the universe? Are we just fleeting ghosts, or does understanding the cosmos give our existence permanent meaning? I challenge you to leave your deepest philosophical thoughts in the comments below. If you are brave enough to continue exploring the beautiful, brutal, and awe-inspiring truths of our universe, become a watcher of the cosmos. Hit that subscribe button, turn on notifications, and join our mission to decode the dark. Until next time, keep your eyes on the sky, and never stop questioning the dark.